In this problem, we're going to need to use Kw. So we've been asked to determine the concentration of hydronium ions and hydroxide ions in a 500 milliliter aqueous solution for homemaking soap that contains 2.6 grams of sodium hydroxide. Now, sodium hydroxide, the nice thing is that there's only one hydroxide ion. So like most strong bases, the concentration of the sodium hydroxide is going to be equal to the concentration of the hydroxide ions. So we can use that 2.6 grams and the molar mass as a proxy to figure out how many moles there are. We have 2.6 grams, molar mass of sodium hydroxide is 40 grams per mole. We also have been given a volume. We know that this is half a liter of solution. Remember that when you're making this solution, that is the solution after the sodium hydroxide's been dissolved in it, so we would not add that volume in. So we can solve first for the concentration of the sodium hydroxide, or of the hydroxide ion. So the concentration of the hydroxide ion, well, we know that for concentration, we want moles per liter. So we have to get moles on top, which means we need to flip our molar mass. We're going to put 40 grams on the bottom. But we don't just need moles on top, we also need liters on the bottom. So we can divide by half a liter. Now, this doesn't give us our answer, though, because we still need to get rid of the grams. So we're going to multiply on top by 2.6 grams so that the grams cancel out with each other. This is going to give us a concentration of 0.13 moles per liter. So that is our concentration of the hydroxide ions here. Now we need to figure out what the concentration of the hydronium ions is. We do know, however, that Kw is equal to the two concentrations multiplied by each other. And all problems you get in grade 12, Kw is going to be equal to 1.00 times 10 to the negative 14. We're not going to have to, the number does change a little bit as you change the conditions, but for us, we're just going to assume that it's not changing. So we know that Kw is equal to 1 times 10 to the negative 14, and that if we multiply the hydronium ion and hydroxide ion concentration together, we're going to get that number. We can use that then to solve for the hydronium ion concentration without having to solve for the pH of this solution. We could do this question last year in grade 11, but we'd have to convert to pH first, then convert to POH, and then convert to POH first, then to pH, and then to hydronium ion concentration. Here, we can just do it in one step now. We can say that the hydronium ion concentration is equal to 1 times 10 to the negative 14. We can divide that number by 1300ths of a mole per liter, which is our hydroxide ion concentration, and then that will tell us that the hydronium ion concentration is 7.7 times 10 to the negative 14 moles per liter, which makes sense. The hydronium ion concentration has to be very low because the hydroxide ion concentration has to be very high. You would not expect there to be lots of acidic ions in a very basic solution.